Identity and access management is a core service in AWS, and you have to have a basic understanding of it since it controls access to everything in your account. In this 3-part series, I'm going to go through everything you need to know about IAM. In this video, I'll cover all the key concepts and break down how things actually work, and then in parts 2 and 3, I'll be walking you through examples in the AWS console. Let's get started. The first question is, what is IAM? It's an AWS service that you use to control who has access to the resources in your account and what actions users are able to perform on them. So then, what's a resource? It's anything in AWS you can work with, such as an EC2 instance, an SNS topic, S3 bucket, or CloudFormation stack. Before I go any further into IAM, I want to make it clear what an account is. An AWS account is a container for your AWS resources, and it has a 12-digit account number. Let's say you're building an application or service. You might create 2 accounts and run a gamma version of your entire service in one account and a production version in another. These 2 discrete accounts allow you to do testing in one without risking affecting the production service running in the other. You access your account and the resources inside with identities, which are also owned by the account. Identities consist of users, roles, and groups, and they provide access to resources in an account. Let's cover users and roles first. An IAM user typically represents a human user, and it authorizes them to perform certain actions. Users have long-term credentials, meaning the credentials don't expire. A role is similar to a user, but it provides more flexibility. A role can be assumed by whoever needs it. This could be a user who needs to temporarily assume a role in order to perform an action, or another service which might need to perform actions on your resources. Unlike users, roles have short-term credentials, which expire after a short period of time, say an hour. It's important not to think of users the same way you'd think of them on a computer, where each user would have its own private home directory where documents and such are stored. In an AWS account, users and roles create, modify, and delete resources at the account level. A resource in an account is not owned by a specific user. You attach identity-based policies to both users and roles, and these policies define what actions the identity can perform. What do I mean when I say that? Well, here are some examples. A user might sign into the console and then perform the action of putting a message in a queue. You might assume a role in the terminal and then use the AWS CLI to perform the action of listing items in an S3 bucket. Or finally, a Lambda function might assume a role to perform the action of reading and writing to DynamoDB and also writing logs to CloudWatch. There's a whole list of AWS services and their corresponding actions that can be performed on that service. These actions might also include creating or deleting a resource, such as a DynamoDB table. You manage these actions by creating policies and then attaching them to identities or resources. So what's a policy? Well, it's an object written in JSON that, when associated with an identity or resource, defines its permissions. There are 2 main types. The first are identity-based. These are permissions policies you attach to an identity which specify what actions they can perform. These policies are broken down further, but we'll cover those later. The second main type of policies are resource-based. These policies are attached to a resource and control what actions a specified principal can perform on that resource. Let's take a look at the example scenarios from before and see what kind of policies need to be attached to the identity in order to allow the desired action. In this example, a user wants to put a message into a queue. Here's the policy which would enable the user to perform this action. The first part of the policy is the version, and you should always just use this value. It's the most recent format that the policies are written in. The next part is the statement. This section contains an array of statements or just a statement itself. The first part of the statement is the effect, and it's set to either allow or deny, which will explicitly allow or deny the action. By default, all actions are denied, which is called an implicit deny. In order to do anything, permissions must be given with an allow. Here, we explicitly are allowing permissions. If there's an instance where one policy allows an action and another denies, the explicit deny always takes precedence and the action can't be performed. The action is written in this service::action format. The action here is send message, which allows a message to be put into a queue. Finally, resource references the resource the action is targeted on. In this example, the star is used as a wildcard, and it means the user can perform a send message action on any queue. Alternatively, an ARN value could be provided instead, and it would scope down the action to a specified queue. ARN stands for Amazon Resource Name, and it's a unique identifier for every resource in AWS. For this next example, we need to grant the role multiple actions across two services. The first statement allows all DynamoDB actions on the table myTable, and the second statement allows 3 actions to be performed: create log group, create log stream, and the put log events on any CloudWatch resource. Roles not only have identity-based permissions, but they also have a resource-based policy called a trust relationship. The trust relationship specifies who, and you'll hear this be referred to as the principal, can get credentials to assume the role. Unlike users, where you're immediately given long-term credentials when you create the user, roles have short-term credentials. The principal who wants to get credentials will have to request them from the Security Token Service, or STS for short. STS will only issue credentials for a role to a principal who has been granted authorization in the trust relationship. The trust relationship looks similar to the identity-based policies we saw before, except it doesn't have a resource property and instead defines a principal. In this example, we set the effect to allow and define the principal as the IAM user, my user. This is who will be authorized to perform the action. The action is STS assume role, and it allows the principal to get temporary credentials for this role from STS. This next example is almost the same, except it sets the principal to be a service principal. A service principal is an identifier for an AWS service and is used to grant the service the ability to assume the role. In this case, Lambda is able to assume the role when executing a Lambda function. Next is groups, and they're pretty simple. They're an identity which contains a collection of users. When you attach a policy to a group, all users in the group will inherit the policies. Users are also able to be in multiple groups. This makes it really easy to manage permissions for a variety of job functions. So let's say you create a few groups, one for developers, database admins, security, and finance. You can then attach policies that the users of these groups will likely need. For example, these are all AWS managed policies, which we'll talk about later, but they basically allow actions relevant to what their name suggests. Now, when I add users to these groups, they'll inherit these permissions. Now that we've covered the 3 different kinds of identities, I want to show some screenshots from the console to make it clear exactly which kinds of policies each one has. I created a user, group, and role. When looking at it in the console, each one has a permissions tab. Under the permissions, you can attach identity-based policies, which define the actions the identity will be able to perform. For the user, I expanded the Amazon SQS read-only access policy so you can see what it looks like, along with the administrator access policy under the group. Remember though, the role also has a resource-based policy called the trust relationship. If you click on that tab, you'll see there's another policy document. In this example, the trust relationship grants API Gateway the ability to call STS to assume the role. When API Gateway assumes this role, it'll be able to perform the actions listed under the permissions tab. Now that you have an understanding for users and roles, we need to learn how to get credentials for these entities in order to access resources. First, we have to understand there are 2 ways to access AWS: programmatic access through the SDK or CLI, and console access through the AWS website. This table breaks down what credentials you need for each type of access. When you create an IAM user, you can download the programmatic access keys. These keys are long-term credentials and will never expire. If you think they might have been compromised, you can always invalidate the credentials and request new ones. The credentials consist of an access key and secret access key. When creating a user, you can also set a password to use to sign into the console. Now looking at roles, when you request credentials for a role through STS, you're given an access key, secret access key, and session token. With these credentials, you can make programmatic calls. For console access with a role, you'll first sign into the console with an IAM user, and then click the Switch Role button and enter the name of a role the current user is authorized to assume. This next example will show some common workflows of how credentials flow. Let's say that you want to read from an S3 bucket using the AWS CLI. So in the console, you create an IAM user named read-only-user and attach S3 read permissions to it. You then select to create access keys, download them to your computer, and configure them in your terminal. At this point, you can send AWS CLI commands using the credentials you configured, and they will succeed as long as they're authorized by the permissions you attached to the read-only user. Now, let's say that you want to write to an S3 bucket. Your current read-only user doesn't have write permissions, so what should you do? Well, You could add write policies to the user, but you really only need to perform a one-time action. This is an opportunity where you might decide to temporarily assume a role which has more permissions. Let's say you have a role named admin role in your account, which allows the read-only user to assume it in the trust relationship. Now, you can make a call passing along your credentials to STS requesting temporary credentials to the admin role. STS then checks the trust relationship of the admin role to see if the read-only user is listed as a principal and is considered a trusted entity. Since it is, STS returns temporary short-term credentials consisting of an access key, secret access key, and session token. You can then set aside the read-only user credentials and configure the new credentials in your terminal. You can then send write requests to the S3 bucket, and the requests that are authorized by the role's permissions will be allowed. This process is referred to as assuming a role. When you're done using the role, you can switch back to the user credentials. I want to show one more example of assuming a role, but this time with a service principal. In this example, say you have a Lambda function with a Python runtime environment, where the application code is going to write to an S3 bucket. You'd use the AWS SDK for Python called Boto3 to implement the logic. You'd then create a role that the Lambda function would assume. The identity-based permissions you'd attach would allow the role to perform the necessary read actions to S3, and the trust relationship would define the principal as a service principal for the Lambda service, granting Lambda the ability to request short-term credentials and assume the role. When the Lambda function runs, it would call STS and provide its service principal. STS would check the trust relationship for the role to verify Lambda is defined as the principal. Since it is, STS would return back short-term credentials. Lambda will automatically configure these short-term credentials in the Boto3 SDK. Then, when the application code makes requests to AWS, it'll use the credentials for the role. And again, only the actions allowed by the permissions granted by the role will succeed. Coming back to policies, let's now cover the two types of identity-based policies. The first is managed policies. These are standalone policies that you attach to multiple users, groups, and roles in your account. These break down further into two types. AWS managed policies are created and managed by AWS and are designed to help make it easier to find a set of permissions you might commonly need without having to write your own policy. An example is Amazon S3 read-only access, which only has read permissions for S3. The second is customer managed policies. These are policies you create and manage yourself. If an AWS managed policy doesn't fit your needs, you might have to write your own. The alternative to managed policies are inline policies. These policies aren't inherently bad, but they're generally not recommended. They're policies you write and attach directly to an identity, and they won't show up under your list of all policies in the console. Next, I want to cover cross-account access. This is when you need to access a resource in another account. A common way to do this is by assuming a role in the other account and then accessing the resource. Let's say that you own account 1 and you need to access a DynamoDB table that's owned by account 2. Someone in account 2 can create a role, let's call it DDB role, that has permissions on the table. Then they'll set the trust relationship to allow the principal, in this case the user in account 1, the ability to call STS assume role. Then we grant the user, my user, the permission to assume the role. We'll create a policy allowing it to call STS assume role on the DDB role. Now the user is able to assume the role by requesting short-term credentials and then make calls to the DynamoDB table. Remember, when you switch to using the credentials of the role, you give up the permissions of the user and take on the permissions of the role. When an action is performed, AWS evaluates all policies to determine if the action will be allowed or not. This section is going to cover the most common types of policy evaluation logic you'll encounter when first starting out with AWS, evaluating identity-based policies with resource-based policies. First, we'll look at evaluating an identity-based policy against a resource-based policy in the same account. In this example, let's say we have a role or user granting some actions on an S3 bucket, and an S3 bucket policy granting certain S3 actions to the user or role. What actions are you able to perform? Well, since both the identity and resource are in the same account, you're able to perform all actions. Now let's say it's the same setup except the user or role is in a different account than the bucket. We now have to apply cross-account evaluation logic. If the user or role allows certain S3 actions on the bucket, and the bucket policy allows certain actions by the identity, what actions can be performed? Well, with cross-account policy evaluation logic, only the actions that both the identity and the resource allow are able to be performed. Let's take a look at some examples. In this example, we have a single account with a user called dev and an S3 bucket called myBucket. The user has these permissions and the bucket has this bucket policy. The question is, what S3 actions is the user able to perform on the bucket? Well, looking at the identity-based policy, the user is granted an allow for S3 get and list actions on all buckets. This would include myBucket. Looking at the bucket policy, it allows the principal, who in this case is the dev user, in the same account, the action of put object on myBucket. Because the bucket and the user are in the same account, we take the union of both actions, allowing the user to perform get, list, and put object actions on the bucket. Now let's take the same example, but change it so the bucket is in a separate account. Again, the user has allow permissions for S3 get and list actions on any resource, which includes the bucket. And the bucket allows the principal, in this case, the dev user in account 1, the S3 put object action on the bucket itself. So same question as before. What S3 actions is the user able to perform on the bucket? Well, the answer is none. And it's because with cross-account policy evaluation logic, both the resource and the identity must both grant permissions in order for them to be allowed. Here, there's no overlap with the actions, so they're denied. Now, if we make one change to this and set the dev user's permissions to have all S3 actions with the wildcard, the intersection between the bucket policy and identity-based permissions of the dev user now includes S3 put object. This is the only action the user could now perform on the bucket. This really covers most of the information you need to get started with IAM, but there are a few final things I do want to touch on. When you create your account, the first identity that's created is the root user. The root user is granted with full access to your account and can perform certain actions IAM users can't, such as deleting your AWS account. You want to protect the root user at all costs. So I recommend configuring multi-factor authentication on the root user and then creating an IAM user to log in for day-to-day tasks. You'll probably want to create an IAM user and give them full access. Administrator access is an AWS managed policy, and it provides full access to all services and actions. The policy document looks like this. Finally, you'll want to be aware of the concept of least privilege. This is where you only grant the minimal permissions necessary to complete a task. For example, if you're running a production application in an account and you only need to look around, you should sign into the console with a user that only has read permissions. This would keep you from accidentally deleting or changing any configurations. There's still a lot more to IAM, like organization service control policies, ACLs, permission boundaries, policy conditions, and more. But this video should be enough for you to get started. The IAM documentation guide is a little dense, but I recommend reading it and coming back to it as you gain more experience. In the next two videos, I'll be showing examples in the console of the concepts I just covered. If you found this video helpful, please subscribe. I plan to do more videos like this soon. Thanks.